Hello everyone. In this video, we cover life annuity immediate. For life annuity immediate, the payments are made at the end of each period. Consider the whole life annuity immediate. Let's get back to the whole life annuity deal first. All right, for annuity deal, if the individual dies at this time point, say between ages x plus kx and x plus kx plus 1, this is the payment. We have the actuarial notation for the actuarial present value, a double dot x. Y is the present value random variable for the annuity deal. We have this expression, a double dot angle kx plus 1, and the expression for a double dot x, we use the more convenient expression for that. For annuity immediate, if the individual dies at this time point and the payments are made at the end of each period, therefore the payments pattern is given by this. The actuarial notation, a sub x. I use the asterisk to denote annuity immediate. For whole life annuity immediate, y, or the present value random variable, is a angle kx. In summation notation, to get ax, we have the summation of this expression, and here we start from k equals 1. To relate the annuity deal and annuity immediate, the difference in terms of the payments, the annuity immediate, we don't have a payment at this time point. And therefore, we can get the relationship ax equals a double dot x minus 1. 1 here is the present value of the first payment of 1. All right, the n-year temporary life annuity. All right, we have the annuity deal for n-year only. So we have a double dot x colon angle n. This is the actuarial notation for the actuarial present value. So we have the expression for y for the annuity deal. And this is the expression for the actuarial present value. For the n-year temporary life annuity immediate, this is the pattern of the payment. And the actuarial present value, okay, the notation is a x colon angle n. This is the PMF expression for y. For the annuity immediate, so a x colon angle n, start from k equals 1 to k equals n, and then sum up the expression due to the power k kpx. Compare these two expressions, or compare the two payment streams. We have a difference here and here. And therefore, we can link up the annuity deal and the annuity immediate. So the annuity immediate equals to the actuarial present value for the annuity deal minus 1. This is the present value of the first payment. And then for the annuity immediate, there's an additional of a payment of 1 at time x plus n. So we add this up at the present value of this payment, which is the pure endowment, NEX. So we have this relationship. All right, we are going to build another relationship. Consider an additional payment of 1 here. All right, so for the annuity immediate, this is still n year. And for the annuity deal, here we have n plus 1 year annuity deal. And therefore, we update the notation. And then you can compare the two streams of the payments. Linking this up, we get another relationship. N-year temporary life annuity immediate equals to an N plus 1 year temporary life annuity due minus 1. And again, this one is the present value of the first payment here. For the N-year deferred annuity, all right, we have the annuity due, N bar A double dot X, the PMF for Y, and the corresponding expression for the actuarial present value. The annuity immediate, we have this payment pattern, the notation N bar AX, the PMF expression, and the corresponding expression for N bar AX. The relationship, this is the difference between the two payment streams, and we can get the relationship. This NEX is this payment of 1 at this time point, and then get the actuarial present value of that. So we have NEX. For the N-year certain and life annuity, similar logic. We have the N-year certain period. So these payments are guaranteed. The expression for Y and the corresponding expression for the actuarial present value. For the annuity immediate, we have this payment stream, the actuarial notation A, and then the subscript X colon angle N with a bar above. For the expression for the annuity immediate, the N-year certain period corresponds to an annuity immediate, A angle N, as compared with the annuity due here. And then the summation notation start from K equals N plus 1. Let's list out all the relationships and the expression for that. All right, we have for annuity due, we have this relationship. And then for the whole life annuity due and the N-year guarantee annuity due. For the annuity immediate, we simply change the A double dot to A. And we get the relationship for annuity immediate. And then the actuarial present value for these types of annuity due and annuity immediate. Whole life annuity due, and then the N-year temporary life, the deferred, and the guarantee. For the annuity immediate for whole life, start from K equals 1, as compared for the annuity due here, start from K equals 0. And then for the N-year temporary life annuity immediate, start from K equals 1 to K equals N. And for annuity due, K equals 0 to K equals N minus 1. For the N-year deferred, start from K equals N plus 1. And then for the guaranteed annuity immediate, the first term is an annuity immediate. And then the summation notation start from K equals N plus 1. All right, these are the expressions that we have covered in this video. Let's take a look at an example. You are given the following 4 quantities: big AX 0.18, big A X plus 15 0.3, And then this notation is simply the NEX 15EX, the pure endowment, 0.55, and interest rate 0.04, 4%. Compute the 15-year temporary life annuity immediate. All right, list out the relationship. We have the relationship between the annuity deal and annuity immediate. And then the YZ relationship for the N-year annuity deal. All right, A double dot X colon angle 15, we have this expression. And we need to get the actuarial present value for the 15-year term insurance. More relationship. We can link up the 15-year endowment insurance with the 15-year term insurance and the 15-year pure endowment. We need to get the actuarial present value for the 15-year term insurance. All right, we have the pure endowment. We need to get the 15-year endowment insurance and other relationship. All right, so we have AX, we have AX plus 15, and then the corresponding pure endowment. From that, we can get the actuarial present value of the 15-year term insurance. Plug in the numbers, and then we get the actuarial present value for that is 0.015. Add this quantity to the pure endowment here, and then we get the actuarial present value for the 15-year endowment insurance, which is 0.565. Plug into this expression. And we get 11.31. And this is for the annuity deal. And we are asked for the quantities of the annuity immediate. Because of this relationship here, NEX is this one is equivalent to this 0.55. Upon calculation, we get the answer 10.86. Another example. For a special 10-year deferred whole life annuity immediate of 100 issued to an individual at age 25. Given that the net single premium is refunded without interest at the end of the year of death if death occurs during the deferral period. And we are given the following three quantities. Calculate the single net premium for this annuity. So here the single net premium is equivalent to the actuarial present value. Let P be the single net premium. Establish a time diagram. All right, during the deferral period, the premium is refunded. So you may consider this as a death benefit. And then if the individual survives beyond the 10-year deferral period, we have an annuity. An annuity amount is 100, starting from age 36. These are the benefits. And then the premium pay at age 25, the net premium is P. Here we simply equate the present value, the actuarial present value of the premium P with the actuarial present value of all these benefits. So we have the P, the premium, equals to the benefit. Okay, for the death benefit, this corresponds to the insurance. A 10-year term insurance, the benefit is P. So we have this expression. And then the annuity immediate of 100 afterwards. This is a 10-year deferred annuity immediate. Benefit 100. All right, solve for the value of P. And this is the single net premium for this policy. The 10-year deferred annuity, this is the annuity immediate. And we are given some quantities related to annuity due. All right, so we have 10 by A25 equals 10E25, and then times the expression A double dot 35 minus 1. We get A double dot 35. We need to get the quantity for 10E25. We can get this quantity from these two numbers, the 10-year endowment insurance and the 10-year term insurance. Using this relationship, we can get 10E25. Substitute the numbers given in the question, and then we get the single net premium for this policy, 336.09. Okay, that's it for today's video. Thank you for watching and see you in the next video.